Tonight, you look outside and discover that Earth has installed a second nightlight. It looks incredible. But the oceans, animals, satellites, and every calendar on Earth have just received a very confusing update. Through your bedroom window, the night sky looks completely different. In this hypothetical simulation, Earth's familiar companion is joined by a smaller, rocky sibling, roughly 1,500 kilometers wide and orbiting farther away at over 570,000 kilometers. On this first evening, they are completely out of sync. While our old moon shines nearly full, the new, more distant one hangs as a sharp crescent. Their combined glow could reach nearly 0.4 lux, brightening the ground enough to make walking easy, though faint stars and the Milky Way quickly fade. Across the globe, balconies fill, live streams trend, and sleep-deprived astronomers scramble to calculate two separate schedules. Romantic moonlight has officially become a two-for-one deal. But this beautiful sky is just the beginning of a massive gravitational tug-of-war. The ocean quickly feels this new gravitational tug. Because tidal force scales by mass divided by distance cubed, this smaller, distant companion would add a modest but chaotic 15% to our existing tides. When both moons and the sun align, coastal waters could surge 22% higher than normal, pushing estuaries like the Bay of Fundy toward unprecedented heights. But this is no simple doubling. Ocean depth and shoreline shapes mean each harbor reacts differently. For fishermen, surfers, and ferry captains, daily planning becomes a mathematical headache. Tide charts would stop looking like calendars and start looking like terms and conditions, leaving sailors to wonder which moon is on duty today. This erratic coastal scheduling is just the first disruption, as the shifting orbits prepare to scramble the timing of our skies. This new orbital alignment turns our sky into a rare geometric theater. Because this smaller moon spans just 0.30 degrees across, compared to the primary moon's 0.52, it can never block the sun completely, ruling out total solar eclipses from its shadow. Instead, we might witness rare double eclipses or a brief moon-to-moon transit, as the smaller sibling drifts across the larger one. On city rooftops, amateur photographers would scramble to capture the crossing, though every upload would be captioned, "My camera doesn't do it justice," giving rise to a new category of two moons, one blurry pixel. But while we struggle with camera settings, a much deeper mystery unfolds for the creatures below. How do animals respond when their trusted nighttime navigation signals are suddenly split in two? Under a dual-moon sky, the natural world faces a chaotic new schedule. For millions of years, creatures have relied on the steady rhythms of a single moon to hunt, migrate, and mate. Now, those biological clocks would experience a sudden, unpredictable upgrade. Take nocturnal insects, which navigate by keeping light sources at a constant angle. Humans would be confused for weeks, but moths would call this the greatest day in history, even if they end up flying in dizzying spirals between two competing nightlights. For an owl, the night shift may suddenly come with better lighting and much less privacy, making it much harder for quiet prey to hide in the grass. Further down the shore, baby sea turtles emerging from their sandy nests might find themselves crawling in the wrong direction, lured away from the dark ocean by a second, misleading horizon glow. Out at sea, coral reefs that coordinate their mass spawning to a precise full moon could experience mistimed cycles, scattering their genes in confusion. Even microscopic zooplankton might delay their nightly rise to the ocean surface, potentially altering marine food chains. While some species would struggle with these new double-phased cues, others might adapt over generations. But as wildlife navigates this biological puzzle, humans face their own immediate reckoning: how to rebuild the calendar itself. For thousands of years, our solitary moon has served as humanity's original timepiece. It shapes the Islamic Hijri calendar with its 29 or 30-day crescent cycles, dictates the timing of the Chinese Mid-Autumn Festival, and inspires Japan's autumn moon viewing traditions, known as tsukimi. Many indigenous cultures even name each full moon to mark seasonal ecological events. But hanging a second mirror in the sky forces a complicated question. Which moon is the real moon? With two distinct crescents waxing and waning at different speeds, traditional calendars would face instant, playful confusion. What would we even name this smaller sibling? Selene II? Or perhaps a public nickname voted on by the internet? Astrologers would scramble to draft entirely new birth charts, while communities might split over which lunar cycle to follow. And would werewolves need a much more complicated work schedule? Of course, existing religious practices would likely remain unchanged, but daily life would get messy. Calendar apps would need a major update, and possibly a therapist. Ultimately, we would have to accept that a cultural system built for one moon simply cannot handle a surprise coworker. Up in orbit, our satellites would feel a tiny gravitational shift. For high-altitude spacecraft, the moon's gravity exerts a force ratio of about 2.43 times 10 to the minus 4, which would rise slightly with a second partner. GPS engineers would not panic, but they would definitely add another line to the spreadsheet, updating orbital maps and firing tiny thrusters to stay on course. This new neighbor also invites big dreams. In a simulated future, space agencies could use Apollo 11 as a bridge to launch new voyages, mapping the surface before sending a crude flyby to build a scientific outpost. After all, humanity has barely planned apartments on one moon, and the solar system has already added another property listing, assuming both bodies remain within their expected trajectories. The real question is not whether two moons can look beautiful together, it is whether gravity agrees. In computer simulations, this three-body dance offers four conditional paths. The system could settle into a repeating stable pattern, perhaps organized by a 2-to-1 orbital resonance where their timing keeps them safely apart. Or, tidal torque could slowly push one outward while drawing the other in, much like Mars's moons, Phobos and Deimos. Over geological timescales, the system might eject the smaller sibling entirely or suffer a distant collision, grinding it into a spectacular ring. The moons may need a cosmic cohabitation agreement, but gravity does not negotiate. This celestial upgrade could create one of our most beautiful skies while rewriting the terms and conditions of Earth itself. What would you name our new sibling? Tell us in the comments, and subscribe to Astral Nexus HQ for more impossible worlds made surprisingly real. Our seemingly permanent sky is a delicate cosmic masterpiece. This simulation reminds us that while a second moon offers endless wonder, our quiet single partner is precisely what makes Earth home.